Hello everyone. Today I am going to explain about the information theory and the amount of information and its properties. Okay, so where we can find out this one, this information theory here is in digital communication. We are having this information theory. Okay, under this we are going to study about different topics, that is amount of information, what is entropy. Okay, so what is discrete information source and what is discrete message, all those things we are going to see here. Okay, so that is what the information theory. So information theory is related to the properties of a message source, a channel, and the noise that is added or the noise interference that will be applied. So if we consider these source messages or message sources, and those will be passes through the channel. At the channel there will be a noise will be interfere with the actual signal. So this total information theory is related to the properties of these message sources and the channel properties, and at the same time the noise interference. Okay, so that is about the information theory, how it relates with the properties of these different objects. Okay, next what we have is the information theory is also called as mathematical theory of communication system. So here information theory is related to the properties of message sources, that is discrete message sources, channels, noise, interference, etc. Next one is information theory is also known as mathematical theory of communication system. Okay, so here we'll use this, or we'll also called as mathematical modeling. We'll do the mathematical modeling of the communication theory or communication system. So that's why it is also called as what? Information theory, also known as mathematical theory of communication system. Okay, so now here it is Shannon, the scientist name is there. So the Shannon is the father of this information theory. Okay, so this is about the introduction. Here we have what is information theory and what is another name for it, and who is the father of information theory. The father of information theory is Shannon. Okay, so Shannon is the father of information theory. Now I am going to define about the discrete information source. So what is the discrete information source and what it will emit or what it will generate. Okay, so it will generate discrete messages. Okay, so when we call a source as a discrete information source, and when we call the message that is delivered from a source is called as a discrete message. So that's what we are going to see here. That is what discrete information source or discrete message. Okay, so here the message that is delivered or the generated from the discrete information source is generally we called as what? Discrete message. But what is the discrete information source or discrete source? Okay, so when we call this any source is discrete source. For that one, here I am considering that suppose a source that will emit discrete symbols. Okay, so suppose consider a source which emits discrete symbols randomly. Okay, so a source I am considering here that will emit a discrete symbols, okay, symbols randomly from a set of fixed alphabet. Okay, it is consists of set of fixed alphabets, and the source will emit the symbols randomly from a set of fixed alphabets. That is here that set I will take it as x equal to capital X is equal to x0, x1, x2 and so on xk minus 1. Okay, so here these are the symbols that are present in this set of fixed alphabet x. Okay, so here what we will consider a source which emits discrete symbols randomly from a fixed alphabet. Okay, and that fixed alphabet I will consider as x is equal to x0, x1, x2 and so on xk minus 1, and their probabilities if I consider as p0, p1, p2 and so on pk minus 1, and that sum of all those probabilities are the probabilities I will represent as p x of xk is equal to pk. Here k is equal to 0, 1, 2 and so on, k minus 1. Okay. So what I am considering here to define a discrete information source is, here I will consider a source which will emit the symbols or the discrete symbols randomly from a set of alphabet. Okay, set of alphabet, fixed alphabet, that is x is equal to x0, x1, x2 and so on, xk minus 1, and their probability of occurrence is nothing but p0, p1, p2 and so on, pk minus 1. Then if summation of k is equal to 0 to k minus 1, p suffix k is equal to 1. That means what? The total occurrence of probabilities is equal to 1. Then that source is called as discrete information source or discrete memoryless source. Okay. So here we have the definition here. So consider a source which emits a discrete symbols randomly from the set of fixed alphabet, that is x is equal to x0, x1, x2 and so on, xk minus 1, with probabilities p0, p1, p2 and pk minus 1. Then if it satisfies the condition that summation k is equal to 0 to k minus 1, pk is equal to 1, then that source is called as discrete information source. So here it will generate discrete symbols and their sum of their probabilities is equal to 1. Then the type of information source is called as what? Discrete information source. Okay. And here what is pk means? I have represented p of capital X is equal to small x suffix k, that is equal to pk. That means if I consider here k is equal to 0, x0 occurrence, probability of occurrence is p0. So if I consider in this one p of x is equal to xk. So here k is equal to, and it is pk, k is equal to 0, 1, 2 and so on, k minus 1. Right? So if I substitute here, probability of occurrence of x0 is equal to what? Here p0. So that's what we have considered here. x0, p0 and x1, p2 and x2, x0, p0 and x1, p1 and x2, p2 like that, xk minus 1, that is pk minus 1. So this is the symbol that is generated and this is the probability of occurrence of them, each and every discrete symbol. So then if the sum of all those probabilities of occurrence of x0, x1, x2 and so on, xk minus 1 is equal to 1, then that type of source is called as what? Discrete information source. Okay. So this discrete information source, whatever the symbols that are generated from this discrete information source is called as what? Discrete message. Okay. So that's what here the definition of discrete information source. Okay. So this discrete information source also called as discrete memoryless source. Okay. So what is discrete memoryless source? Why it is called as discrete memoryless source? Whatever the event or whatever the symbol that is generated, okay, so the generation of that symbol or the emission of that symbol cannot be depends on the probabilities of the previous ones. So that's why it is called as what? The memoryless source, discrete memoryless source. Okay. Now we'll go with what is uncertainty here. So this is the definition of our discrete information source and discrete message. So next we have what? Uncertainty. Okay. Then what is uncertainty generally? Okay. So generally the uncertainty means we don't know whether it comes. Suppose two events must be occur. Okay. Out of the two events, suppose x and y are two events that has to be occurs. Okay. Or the symbols x and y are two symbols. Okay. Which one will occur? That is nothing but uncertainty. We don't know which symbol will occur first or which symbol will emit out of these. Suppose if I consider here we have x0, x1, x2 and so on, xk minus 1. So out of all these symbols, which symbol will occur, we don't know. Okay. That means that is called as what? Uncertainty. After after emission of any symbol, okay, so there is no uncertainty because already it is done, already it is obtained, already it is generated. Okay, so we know that suppose X is occurring, okay, or X is emitted. So there is no confusion or there is no uncertainty in that one. Directly X is emitted there. Okay, whenever there is no occurrence of any event, okay, at that point the uncertainty will be present. Okay, that's what we have. We will see how it will be. So what is uncertainty here? I will consider, to explain that, I will consider emission of a symbol X equal to Xk. Here what is the symbol? That is Xk. So it is a symbol that is X equal to Xk with probability Pk. With probability Pk. Then if probability of occurrence of this Xk is equal to 0. Okay, probability equal to 0 means, is there any possibility to obtain that symbol? There is no possibility. That is impossible for the occurrence of that symbol. Okay, that's what here we have. So if Pk is equal to 0, the occurrence of this symbol is impossible. Okay, so next, if Pk equal to 1, the occurrence of symbol, Pk is nothing but the occurrence of the symbol Xk. Xk is the symbol and the probability of occurrence of that Xk is nothing but Pk. Okay, so here if Pk is equal to 0, there is impossible task. Okay, that is impossible to occur. That's what here I have written. So if Pk is equal to 0, the occurrence of symbol Xk is impossible. Okay, similarly if Pk equal to 1, then the occurrence of that symbol Xk is possible and it is sure occurrence. Compulsory it will occur because the probability of occurrence is equal to 1. Okay, so therefore here the probability of occurrence of this Xk is equal to 1, that is the possible outcome. Okay, so next these two are okay. That means we have the probability, that is Pk is equal to 0. Okay, that means the probability of occurrence of that event is equal to impossible because Pk equal to 0. That means the occurrence of that event is impossible. Similarly, if you Pk equal to 1, so we can say that surely there will be an occurrence of the symbol Xk. Okay, occurrence of an event Xk. So that is what here the meaning of Pk equal to 0 and probability of occurrence of Xk equal to 1. That is the meaning. But where this uncertainty we will consider. So I have taken this heading as uncertainty. Okay. So in these two cases, is there uncertainty? Surely one thing will indicate, that is Pk equal to 0 will indicate there is no possibility of occurrence of that event. Okay. If Pk equal to 1, it will indicate there is surely there is a possibility of occurrence of that event. Okay. So there is no probability or there is no possibility if you consider Pk equal to 0. Okay. That means it is completely decided. That means already we know that the possibility is there if Pk equal to 1. That means is there any uncertainty? So if you know that X will come or Y will come, okay, if you know that there is no uncertainty or confusion, which will come, which one will come, X will come or Y will come or Xk will come or X1 will come, okay, whether it is not coming. So that means if you don't know the probability, then there will be a uncertainty. Okay, if you know the probability of occurrence, so there is no uncertainty. Okay, if you know that, clearly we know that there is a occurrence of that event, so there is no uncertainty. When the uncertainty is present is when we don't know the probability of occurrence of that particular event. So that is what the uncertainty we have. Okay, so in these both cases, if I consider this one is the case 1 and this case 2, there is no uncertainty or there is no surprise, because when we call surprise means if we don't know whether that is coming or not. Okay, so suddenly it will comes means that is nothing but a surprise. Okay, but here already we know that Pk equal to 0 and Pk equal to 1, so there is no surprise. Okay, and the same time there is no uncertainty that is present in this case. Right, so that is about the uncertainty. Right, before event X equal to Xk occurs, that means what I told, before the event occurrence. After occurrence there is no uncertainty or there is no surprise. Okay, but if the event occurs, if the event not occurs, then there will be a surprise or uncertainty will be present in this one. So that is the point. It is very important point when the uncertainty will be present. So before the event x is equal to xk occurs, then there is a amount of uncertainty will be present. So that is called uncertainty. What is uncertainty? Right? So this is about the uncertainty, and here we have the introduction, and next one is discrete information source definition, discrete message, and now we have uncertainty. Okay? Under this information theory, we are going to see about what is amount of information, and what is entropy, and what is the average entropy and their properties. Okay? So this is about the introduction of the information theory. Thank you. Thank you for watching. Subscribe our channel.